These mirrors focus solar radiation and convert it into steam, and I do a lot of experiments with different types of mirrors to find the best type which can convert solar radiation into thermal energy at this cost, half a cent per kilowatt hour, and it is about 10 times cheaper than heat from natural gas. Such a low cost of our solar heat allows a turbine to produce electricity so cheap that it wins competition against thermal and nuclear power plants, and combining the following three ideas could reduce the cost of our solar electricity by several times additional.
The first idea is used by these large solar power plants which convert solar energy into thermal energy with a temperature of almost 400 degrees Celsius. My previous videos have often described how this thermal energy generates electricity using a turbine and similar heat storages which allow the same turbine to produce electricity at night. Our second idea is also well known, and for example this solar station has been in operation for 10 years, and these solar collectors heat water at 50 degrees which is used to produce copper. Now I am showing another example in the desert, and here we can see many mirrors that convert solar radiation into steam, which is used to extract oil. This is another example in California, where many mirrors heat vegetable oil about 200 degrees Celsius to produce snacks. In addition, we can find several hundred other examples where solar energy is converted into thermal energy which is used for industrial processes in the food, textile, chemical and other industries. Our third idea is also well known and used very widely. For example, this solar station which heats thermal oil to over 300 degrees Celsius. This energy is spent on the simultaneous production of both electricity and thermal energy to heat water, and engineers call this simultaneous production of electricity and heat by this term. So, let's combine those three ideas with similar mirror systems that could give us huge amounts of very cheap thermal energy. We understand that similar low-cost mirrors must cover many square kilometers, and therefore their power can be comparable to nuclear reactors. The thermal energy heats a huge amount of substance inside similar heat storages to a temperature of approximately 300 degrees Celsius. And one of my old videos showed many types of heat storages made from concrete, gravel, sand and other cheap materials. This hot substance produces steam for a turbine not only during the day but also at night and on non-sunny days. The turbine not only rotates an electric generator but also releases a huge amount of thermal energy which is not emitted into the atmosphere but is transferred to some factory. Now I will prove why the sales of the thermal energy can reduce the cost of the electricity several times. Let's assume that we do not sell the thermal energy but emit it into the atmosphere, and let the cost of our solar heat not be half a cent per kilowatt hour but 4 times worse, 2 cents per kilowatt hour, which is written here. This case leads us to this very bad cost of our solar electricity. But now I take into account the sales of our thermal energy to some factory, which are added to our formula in this way. We see that these revenues from the sales have reduced this cost of our solar electricity by almost 3 times to the level of 5 cents per kilowatt hour. Now we will compare it with the first formula, and we see that the second formula takes into account these revenues from the sales, but it is well known that the sales will noticeably reduce this turbine efficiency and also slightly change these values. It is obvious that such effect of reducing the cost of our solar electricity will be different for different cases, and for example, let's consider the case of solar power plants of this type. If the heat cells are not used, these power plants lead us to this cost of electricity. This is the same case, but now we sell that thermal energy to some factory, and the sales are taken into account here. Let's compare these two formulas, and we are surprised to see that those heat sales do not reduce the cost of electricity, but on the contrary increase its cost. Of course, these heat sales revenues reduce the cost of electricity, but other causes increase its cost. The main cause of the increase in the cost is the decrease in this efficiency of converting solar energy into electricity. In addition, the cost of electricity increases slightly due to the decrease in this capacity factor and the increase in this value, but improving this energy block cost slightly reduces the cost of electricity. Nevertheless, let's pay attention to this selling price of our thermal energy. It is obvious that increasing this price reduces the cost of our electricity, and for example, now the increase in this price of heat has led to a decrease in this cost of electricity by 1.5 times. Just now I talked about the simultaneous production of electricity and heat, but this is not the only option. Another option appears if we use large heat storages, as described in this old video 8 months ago. That video described that during the summer months, millions of square meters of our mirrors heat a large mass of soil to several hundred degrees, and this thermal energy will be stored for several months to generate electricity in winter. Now I am showing our artificial mountain, and the soil temperature on this periphery of the mountain is much lower than in the center of the mountain, and such temperature differences significantly reduce these heat leaks. This temperature difference occurs if we take heat here on the periphery of our mountain and sell this heat to a factory. It is interesting that the factory may require thermal energy of different temperatures, and for example, the thermal oil of these pipes can be used to generate large amounts of steam for industrial processes of the factory. These pipes give higher temperatures in the form of hot thermal oil that circulates between our heat storage and the factory. It is also obvious that these pipes on the periphery of our artificial mountain can heat water for the hot water supply of the factory and for its industrial processes with a temperature of less than 100 degrees. So, the thermal energy of our artificial mountain is used not only to generate electricity, but also to sell thermal energy to a factory or several factories.